Hello all. We'll be studying another new program, and that is you need to write a program to demonstrate working of stack using linked list. You all know there are two types of data structure. One is physical data structure and another is logical data structure. Logical data structure. In the physical data structure we have got only two. They are stacks. No, they're not stacks. The physical data structure we have got arrays and linked list. We call them as physical because they are simply different ways of representation, different ways of representation of data in the memory itself. Data in the memory itself. Okay. That's why we call them different data structures physically. Okay. Now, if you come to logical data structure, they are stack, queues, and then trees and graphs. Trees, graphs, hash tables. These actually can be built using arrays and stacks, arrays and linked lists. Means we can implement stack using arrays. We can implement stack using linked list. We can implement queues using arrays. We can implement queues using linked list. Same way, trees can be implemented using linked list. Trees can be implemented using arrays. Right. So actually we'll be using combination of linked list and arrays to implement trees, graphs. We'll see them later. But if you look at this question, this is going to deal with this part, that is stack part. We are going to implement this stack. Implementing stack as arrays is very simple. Simply you need to remove the first element or add the element to the end. But implementing using linked list is a bit challenging because programs of linked list itself, they are a bit complex, and we will be seeing this part today. Okay, let me show you graphically how actually the adding and deleting of the elements take place. Whenever you're implementing, already I have explained a program, the full program of linked list in a different video which has taken almost 1 hour. You must watch that video, because if you don't watch that video you will not understand how the stack is working, because the base lies in the linked list itself, especially in this question. Okay, let me show you. In the linked list we'll be having a head part. Initially it will be null. Okay, we'll be having, I'll just put a cross here. Or else in our stack we are going to consider it as top element. Okay, instead of head I'll be using top. Whichever the element this top will be pointing, that element will be popped. If you want to delete element, if you are pushing, then the element will be pushed in this place. Okay, now let's imagine that I want to add 10 in our element, in 10 in our stack. For that, what is the first thing? You need to create a node. Okay, this node will be having two parts. As you know, it is data part and it is next part. In this you are going to write 10 and you are going to link this part to 10. Okay, for that what you will do, you will take the address of this one. If address is first, you are going to have first in this, right? You are going to have first in this, right? We'll just create this one bit bigger and then write first in this, and this will be null. This way this top will be pointing to 10. Now if you just try to pop the element from this one, automatically 10 will be popped, and again we'll be having, if you just pop the element, we'll be having again a null in the top. If top is null, then we know that we cannot delete an element or pop an element because it is underflow, right? The same way, now let's take another scenario. We have got null initially and you want to add element 10 here, and then you want to add 20. We have got again 30. In this case, this will be top. It means, see, initially we have added 10. 10 will be here actually, and the next element added will be between this top and the first element. I'll show you that also. Just we'll clean this once. We'll just see here. Now imagine this is 10 and here it is null. This is first. Now this is first and it is pointing here, right? Now if you want to add another element, automatically what will happen is that element will be created somewhere in the memory, and you want to add 20. Whatever the element added just now, that will be considered as top. So if it is second, now in this we'll be having second, and this will be pointing here, and here I'll write first. I'll be adding it here, and this will be discarded. The same way, if you are adding 30, we'll be having another node 30. Now to make sure that this will be pointing in the correct direction, we'll be having what here? We'll be having third will be written here, this will be pointing here, and this will be pointing to the second element, and in this, at this time, this will be discarded. Now you can see first top element is 30, now it is 20 and 10. These things are gone, right? These links are not present now. Okay. Now if you want to delete an element now, automatically this needs to be deleted because this is the top element recently added. That is first in, first out. Alright, recently we have added 30 and we need to remove it. For that, what we need to do? Just we need to change this value, make it second, just free this part. So you just free this part, and if you make it second, this will be pointing to this one. Right, in this way we have popped now 30. Now next will be popping 20. So this is implementation of stack, and this is much more simpler than the linked list programs, because you have got pushing the element means adding the element in the first place only, right? You need not add in between the elements in place of stack implemented using linked list. Okay, we'll see a graphical representation once. We'll go to a website, csvisualtool.com, and stack ln. This is very nice tool. You can see this is head. In our case, we had considered this to be a top. Okay, now I want to push element 10. Okay, just write 10 here and say push. As soon as I push, you can see 10 is written in the linked list, and that is linked to the first element. So the address of this element will be written in the head part or the top part. If I write 20 here, now see what will happen. Just say push. This 20 will be written here now, and this element will be linked to head, and this element will be linked to 20, as I have explained previously, and the top is pointing to this one. Now if I try to pop the element, if I just click on this pop, you see 20 is taken out, popped value is 20, and that memory is freed. So now it is pointing to 10. Okay, this is simply a visualization of linked list. Now if you want to add again 56, just push 56, it will create a memory, and then head will be pointing to this, and then you can see there is a procedure pushing the element. For that you need to create a new node, and then new node next points to the head, means next of the new node will be pointing to the head, and then head points to the new node. Head will point to the new node, this will be point to the this element, and then increment the size. At present size is 2, and then you are ending the procedure. In this way, adding of the elements will add one more element. 41 will add, just push it, 41. Then this will be connected to this, this will be connected to this. This way we have got a stack. Now if I just pop, you can see popping of the elements takes like this. You can actually visualize each and every data structure using this tool. This is very good. Okay, I will go for the program. You can observe here we have got header files std.h and stdlib. Here we need to create a node. This node is going to have two parts, one is data part and next part. Data type of this data is int, and data type of the next is address pointing to the new node, that is struct node. Now for pushing the element, you can observe we have got one function for pushing the element, we have got another function for popping the element, because we are going to do only two operations, and another is display operation just to see all the elements. Okay, and then we have got main function. Here we will do pushing and popping or displaying the elements. Fine. Now if you observe this push part, whenever you are pushing, you need to know the procedure. You need to create a new node. Okay, if we did not get any node, it means if the memory is full, obviously we will not get a node. At that time it will be stack overflow. Okay, and we will be returning. If it is not, if you have got some new node, if you have got some address of the new node, then data part of that will be equal to the data whatever you have passed here. In the push we are passing data and then the top element. Okay, and then new node next, whatever the new node next will be equal to the address that was stored in the top initially, right? And then the top value becomes new node. It means we are directly connecting the new node to the top, and whatever was stored in the top is stored in our new node. This is the procedure that you have seen just before, and we are going to say pushed onto stack, and the value we are going to print here. Similarly, whenever you are popping the element, if top is equal to null, it means if there is no value in the null, we are going to print stack overflow and return -1, because you see it is going to return an integer, so you should make sure that you will return some value. In this case it was void, so there was nothing to return, so return is having no value, right? Now we are going to store a temporary value which will be having a top. Okay, whatever will be there in the top will be stored in the temporary value, and then temporary data will be stored as popped. Okay, it will be stored in the pop because we are going to delete this temporary now, and then top value will become top of next, means whatever was there in the top value we are considering, we are going to assign it to a next value to the top, means the next, it is nothing but the address of the first element. You can see initially top had some value, and address of that element will be stored in the pop. Okay, for the first value there is something next, and that next value will be stored in the top. You need to understand this step because this is very important. And you are going to free the temp value. Now you can see temp is nothing but a value in the top, and we are going to free that particular node, and then we are going to say popped %d, and we are going to return the popped value, because if you want you can show the popped value here, right? And then afterwards for displaying, if top is equal to null, you know that it will be a empty stack, and then you are going to return from here only. If not, we are going for struct node temp is equal to top, means we are using a temporary variable for tracking each and every node. Initially it will be equal to top, and then stack elements are, we'll check whether temp is equal to some address or not. If it is equal to some address, then we are going to print the data of that one using temp data, and then set temp is equal to temp next. This particular code was already explained in case of display in the linked list program. You can watch that video, it is very simple. Fine. And then at the end you are going to print null, right? In the main function you can see we are going to create a struct node, and we are going to name it top, initially top will be null. Now if you are pushing a element, you need to pass the address of the top as well as the value that you want to add. Okay, now we'll be removing some of the parts and I'll be demonstrating you live. Go here, we'll just clear it. GCC stack linked list. Okay, no errors. /a. If I just execute, you can see the output of this pushed 10 into stack. So initially we have pushed 10, then we have pushed 20, then we have pushed 30. So at present 30 should be the top element. You can see 10, 20 and 30. Whenever you are popping the element, it will pop 30, right? And then whenever you are popping again another element, and after popping the element you can see the stack values. It is 20, 10 and null. And then again popping, it will pop the next top element, that is 20. Now we are left with 10, and again popping the element, we are left with an empty stack. Right, now I'll try to add another element here. For adding another element, say push and pass the address of top. Okay, comma, you need to, if you want to pass 34, you can pass anything here, but you need to remember that you will be passing first top address and then the integer. Now you try to execute this code. Any changes in the code, you need to compile it. I have compiled. Now execute. Now you can see I have pushed 10, 20, then 34. Recently I have written, and then 30. You can see clearly stack elements are 30, 34, 20 and 10. And if you pop, we have got 30 on the top, so top will be deleted. So it is popping 30 now, and the stack elements are 34, 20 and 10. See, similarly pop 34 from stack, we have got 20 and 10. Similarly pop 20, now at the end we have got 10. Again if you write another pop, pop will take one parameter, that is address of pop, address of top, and then you just see display top, right? Just try to execute this, we'll see the end result. When you are trying to pop once again, you will see this output, stack is empty. We have popped the last element, and at the end we have got stack is empty. That's all. Thank you.